Hello, and welcome to Leica Geosystems BLK Autonomous Fleet Week. This week we are showcasing our autonomous reality capture portfolio. Today's session is the second of 4 sessions designed to highlight and deep dive into each of the autonomous reality capture products. I'm Brian Baker. I, along with my colleague Balint Rieger, will present on the BLK2FLY autonomous flying laser scanner. The Leica Geosystems complete BLK portfolio consists of 6 hardware platforms and a software suite that brings all of the data together. The BLK360, BLK3D, BLK2Go, BLK247, BLK2FLY, and BLK Arc. The autonomous reality capture portion of the portfolio consists of the BLK2Go, BLK2FLY, and BLK Arc. I strongly encourage you to sit in on the other sessions to get a full picture of the capabilities of our solution suite. What are we going to talk about today? First is the Leica BLK Autonomy Vision. Then I'll give you an intro into the BLK Autonomous Fleet, tell you a little bit about myself and Balint, and then I'll go over the BLK2FLY technology, including the hardware and the software. Following that, I'll give you a brief glimpse of some BLK2FLY data. At that point, I'll turn it over to my colleague Balint, who's going to talk about the import process, but more importantly, he's going to give you case studies, including a railway bridge, a mine elevator shaft that was a heritage project, a refinery, a high-rise building, and a support wall. He'll pass it back to me at that point, and I'll close out our session with a summary. So what is the BLK Autonomy Vision? It's to make reality capture autonomous from capture and acquisition to processing and creation of deliverables, insights, and experiences. BLK Autonomy is robots and platforms that require no human intervention, Grand Slam technology and real-time laser scanning, AI and machine learning enabled data processing. Autonomy is how these robots, sensors, and software work together to create a complete autonomous reality capture system. As I mentioned earlier, the BLK Autonomy portfolio includes the BLK2Go, the BLK2FLY, and the BLK Arc. Now for a little bit about ourselves. As I mentioned earlier, my name is Brian Baker, and I'm the UAS Sales Manager for Leica Geosystems in the US and Canada. I've been with Leica for 8 years, but I've been a geospatial professional for the past 35 years. I'm an ASPRS certified mapping scientist in UAS. I'm also a commercial pilot as well as a UAS pilot and a certified flight instructor. And when I'm not traveling and selling the BLK2FLY, I can usually be found at the airport, either working on planes or giving flight instruction. My colleague, Balint Rieger, is a product specialist out of our reality capture office in Sweden. Balint's been with Leica Geosystems for 2.5 years. He's a civil engineer with a background in road construction. And when Balint's not selling the BLK2FLY, he's spending time with his 2 hunting dogs and loves sailing. So now I'd like to introduce you to the Leica Geosystems BLK2FLY. The BLK2FLY is an autonomous laser scanning drone that allows you to scan from the air. Objects on the ground and protrusions from structures create shadows for ground-based scanners that require additional setups to fill in or are just completely unattainable due to logistic or safety issues. The BLK2FLY combines multiple sensors and technologies to allow you to capture reality like never before. Today I'm going to present a short overview of this amazing system. So let's get started with the BLK2FLY technology. The BLK2FLY is a completely integrated, small, lightweight, portable, intelligent, and easy-to-use system. There are no external payloads to attach, and all the sensors work together through an advanced artificial intelligence and machine learning flight controller designed by Leica Geosystems. It includes advanced obstacle avoidance, and no special training is required other than a UAV pilot's license. When I say small and lightweight, I'm referring to the approximately 24 inches wide and 21 inches long, and a weight of 5.7 pounds, including the battery. When I say portable, I'm referring to the fact that the BLK2FLY wings fold up for easy storage and transportation, cutting the width almost in half. The BLK2FLY incorporates multiple sensors and communication technologies. First, of course, is the BLK2FLY LiDAR scanner. Scanning at 420,000 points per second at a range of 25 meters, the full dome scanner captures everything in front, beside, above, and below simultaneously. Next is the full dome 5-camera imaging system, which provides a live view for the pilot while flying and an 8-megapixel dome image for project visualization and point cloud colorization. The radar detectors on the sides and the rear of the aircraft provide obstacle avoidance around those sides of the aircraft where the LiDAR doesn't see. It can detect obstructions as small as 5 millimeters or 1/4 of an inch. The BLK2FLY has a full constellation RTK GNSS receiver capable of positional accuracies down to 1 to 2 centimeters with network RTK corrections like our Leica SmartNet. The Wi-Fi and LTE connectivity provide connection to the tablet controller and GNSS RTK corrections through the Leica BLK2FLY's own cellular connection. The hot swappable battery system provides about a 30-second turnaround time between flights to continue your collection as productively as possible. Let's take a little closer look at the LiDAR sensor. The full dome 360 degree by 270 degree LiDAR sensor is the same sensor used in other BLK autonomous reality capture products. The sensor is collecting data above, in front of, below, and 45 degrees behind the aircraft as it flies. The sensor is fully integrated to the flight controller for data collection and obstacle avoidance. The full dome 5-camera imaging system collects an 8-megapixel panorama dome image every 2 seconds during flight. This imagery is used for point cloud colorization and project visualization. Upon data import, you have the option of how frequently you want the imagery placed in your project. The cameras are also used to assist in flight stabilization. Unlike any other drone, the BLK2FLY uses simultaneous localization and mapping, or SLAM, combined with RTK GNSS, which is the grand in Grand Slam, to learn about and adapt to its flying environment. The GNSS, LiDAR, and radar provide information to the artificial intelligence in the BLK2FLY flight controller so that when the BLK2FLY encounters an obstacle or disturbance in its path, the flight controller determines the best course of action to take. Let's take a quick look at the obstacle avoidance. As the BLK2FLY maps its environment using Grand Slam, the artificial intelligence in the flight controller determines the best path to take, either around, over obstacles, or just hold in place if it cannot determine a path forward. The RTK GNSS provides accurate flight paths during scans and also provides georeferencing to the LiDAR point cloud. Next, we're going to take a quick look at the operation of the BLK2FLY. The BLK2FLY is controlled by the Leica Geosystems BLK2FLY Live app that runs on the Apple iPad Pro. The BLK2FLY Live app provides information regarding the airspace, flight planning, a live feed to the pilot, and of course all the settings that control how the BLK2FLY operates. We can check our airspace using the airspace portion of the BLK2FLY Live app to make sure that we are within flight regulations, or to see if we need any special authorizations for the area that we're flying in. Leica Geosystems has partnered with AirMap to provide you with real-time airspace information so that you're aware of the airspace requirements that you're in your operating environment. The BLK2FLY app provides the pilot with 3 different views. The first on the left is the live view, which displays the video feed from the 5-camera imaging system. In this view, we can fly the aircraft with gesture controls, such as swiping left or right to turn the aircraft, double tapping on the image to fly forward in that direction, zooming in or out of the video to fly the aircraft forward or backward. With gesture controls, in addition to virtual joysticks, even a novice can easily fly the aircraft. The live view also allows the pilot to create a scanning mission of what the pilot sees in the live view. The 3D scan view in the center of the screen provides the pilot with what the BLK2FLY has mapped with his LiDAR. This view can be moved, rotated, and zoomed to see the subject from every angle and visually confirm they've obtained all the desired data. In this view, by tapping any one of the points in the scan, the aircraft will fly to that position and continue collecting data. This is another method for easily maneuvering the aircraft for increased productivity. Finally, the aerial image in the right view provides a satellite backdrop for planning an area collection or just seeing where the aircraft is relative to its surrounding environment. In any of the views, simply press the plus button in the upper right corner and select the style of mission you'd like to perform. Surface recording is for vertical surfaces and facades. Area recording is for horizontal areas such as roofs and lots. Finally, manual recording allows you to just collect everything the copter scans while you manually fly the aircraft. Let's have a look at each method in a little bit more detail. Scanning a surface. The steps for scanning a surface include takeoff, positioning the BLK2FLY, generating a scan mission, and then the BLK2FLY just goes and gets it. In this view, we're going to press the plus button to create a surface recording, and then we're going to tap in the live view to create a polygon around the area that we want to collect. We can adjust the points, we can add points, and when we're done, we hit the checkbox, and the BLK2FLY automatically creates an optimized flight plan for that surface. By pressing the play button in the bottom of the screen, the BLK2FLY goes and captures the data. In this image, you'll notice that the BLK2FLY, as it scans the facade, will detect the portico protruding from the facade. It will back away from the facade and navigate around the portico as it continues on its mission. In the live view, we can see the LiDAR data, or in the 3D view, we can see the LiDAR data as it's being collected in real time while the BLK2FLY flies this mission. On the second pass of the mission, the BLK2FLY will again detect the portico. It will back away from the facade, go around the portico while collecting that data as well, and then once passed safely, it will move back in towards the facade to continue on its mission. You can see in the lower left-hand corner how the LiDAR data continues to be filled in for the pilot's visualization to make sure that they are getting all the data that they anticipate collecting. So we'll let this run to the end, because then we'll see in a moment, we'll switch to the live view, and you can see in the cameras what the BLK2FLY sees as it's flying. So here's the live view as the BLK2FLY traverses the facade of the building. Views are selected in the lower left-hand corner. Right now you see that the live view is highlighted. And the center option is the 3D view, and the left option is our 2D image. Once the BLK2FLY has finished collecting the surface, it will ask you if you want to continue collecting data, allows you to do another mission. We could move to the side of the building or collect the roof of the building. If we want to collect the roof of the building, that would be scanning an area. Again, takeoffs and landings are fully automated. We position the BLK2FLY, press the plus button to create an area mission. We can adjust our altitude as necessary, but because of the collision avoidance, we don't have to worry about the BLK2FLY running into anything on the roof. It will follow the roof line as the roof goes up and down, and it will avoid any obstacles like chimneys or parapet walls or anything like that. You can see from the live or the 3D image that the BLK2FLY flight path actually intersects portions of the building, but the BLK2FLY simply goes around those obstructions to continue on its flight path. Once the BLK2FLY's battery has been exhausted, it will automatically return to home. The operator doesn't need to do anything. The BLK2FLY will come back to either its launch point, or you can change the definition to have it return to its where the controller is located, or you can just have it land in place. Hot swapping the battery only takes about 10 seconds, and when you press the takeoff button again, the BLK2FLY will lift off and then continue on its mission right where it left off. In manual collection, the BLK2FLY allows you to manually position the aircraft using virtual joysticks, using touch to fly in the 3D mode, or we can use gesture controls such as swiping on the tablet screen to turn the aircraft left or right, pinch to zoom in or out for the aircraft to fly forward or backwards, and double tap anywhere on the live image screen for the aircraft to fly forward in that direction. So even a novice without any drone flying experience can easily fly, operate, and collect data with the BLK2FLY. This is an example of touch to fly in the 3D mode. We simply tap on any one of the points in the point cloud, and wherever the BLK2FLY is, it will fly to that point, facing that point while continuing to collect data. An operator could very easily simply tap multiple points in the 3D view, and the BLK2FLY would go and capture that data. So the gesture controls make the BLK2FLY very simple to fly. Traditional joysticks are also available for the pilot if you want to fly it as a regular drone. So now let's take a look at some of the results of the BLK2FLY. BLK2FLY data is downloaded into Cyclone Register 360. From there we can collaborate, do meshing, and modeling of the BLK2FLY data. The Cyclone Register 360 collects data from the entire BLK product family, as well as other scanners and point cloud data sources. Register 360 is an easy-to-use yet powerful collection and processing software. The workflow is streamlined into one software regardless of which device was used to collect the data. In this example, we have a project where we've combined 8 flights into one bundle to create a completed building. We can easily add BLK2GO, BLK360, or BLK ARC or RTC 360 data, or any point cloud data to this project. Balint will show you this project in a little bit more detail shortly. Here's some videos of different projects that I've personally flown Upper left is a 10-story office building. Upper right is a historic building in New York. Lower left is a refinery, and lower right is a railroad trestle bridge. The BLK2FLY data, as well as all the BLK product data, can go to a variety of different softwares for different deliverable extractions depending on your particular application. At this point, I'm going to go ahead and hand off the presentation to Balint, who's going to show you some case studies with the BLK2FLY.
Thank you for this thorough presentation of the BLK2FLY, Brian. Let's take a look at how does the import process look like and go through some interesting use cases from the last couple of months. So for the import, there's two ways to work with the data collected by the BLK2FLY, and no matter which one you use, as always with Leica sensors, you own the data and you have full control over what should happen with it. So the online workflow is based on HXDR, the coming cloud registration platform. In this case, you can upload the raw files directly from the BLK2FLY using the built-in SIM card or the office Wi-Fi network, or you can use a computer for uploading. The files are then processed, registered, and meshed automatically, and the final point cloud and mesh can be viewed, downloaded, and shared in any browser, so you can give access to your colleagues and to your customers in this web-based solution. A little bit later, advanced cleaning and analysis possibilities are also coming into HXDR, like cloud-based BIM progress monitoring, deviation analysis, and many more. The offline workflow uses Cyclone Register 360, our registration software. After downloading the raw data using Wi-Fi or USB cable from the BLK2FLY, you can simply drag and drop the files into Register 360, choose your import settings, and hit import. Based on the GNSS coordinates, your flights are coming into the right place automatically. You just need to clean the dataset, link your flights together, check the results of the registration, and you are ready to export the point cloud to your chosen file format. Register 360 can export to many formats, included but not limited to our LGS reality capture container file, LAS, E57, RCP, and a few more. Now let's dive into our first use case for today. It's a quite complicated structure, which is not that easy to document. This dataset was collected with 5 short flights, and it's used for planning the upcoming renovation of this bridge. As this is a very old structure, there's a heritage aspect to consider, and the point cloud produced by the BLK2FLY provides a detailed and accurate base for modeling, and even the marking of each small details as needed on this bridge. It also gives information about the surroundings that can be useful for the planning of the project, logistics, and so on. The point cloud is automatically georeferenced based on the GNSS position from the BLK2FLY, so there's no need for a larger surveying team or control points on the ground in this case. There's a serious safety aspect to mention here. There was no need to go on the bridge or even near the tracks. The operator could collect the data here without any stop in the railway traffic and from a safe distance. The point cloud from the BLK2FLY here allows for a thorough planning before the start of the project, and it helps to minimize the project time, save costs, and shorten the downtime on the railway line, and also minimize the risks. Our second use case is equally interesting. This is a mine elevator building that is more than 100 years old, and it's located in northern Sweden, next to one of the big mines in that area. The building is an important landmark of the Swedish mine industry, and it's well known by the locals. This is why the mine company decided to create an accurate digital twin for preservation purposes. The size and the many details on the elevator called for a method delivering accurate measurement and visual information as well. The building was captured in a single 11-minute-long flight, and it was processed in Register 360. As you can see, the point cloud is extremely detailed, and it works as an invaluable ground truth for the modeling work. You can see the level of detail on the wheels of the elevator. This is a raw point cloud, and absolutely no manipulation or cleaning was done here. Isn't it amazing how all the tiny details on the wheels and the surrounding steel structure is visible here? It makes the modeling work much more easier and more accurate. I love this data set. The elevator, and this is an interesting additional information, this elevator building is located in an area that slowly becomes dangerous because of the old mining activity a long time ago underground. And therefore, the inhabitants and even some buildings in this area were relocated to another city nearby. This makes the need for the accurate documentation even more important, since we don't really know how long this area stays safe for going there to take measurements. So what you see here is that in Cyclone 3DR you can go through the whole point cloud in slices, and you can focus on that area that's needed for your modeling work. You can focus on the steel structure, you can get the placement of the windows, you see the edges of the stairs, and of course you can also model up all the wheels on the building. The next use case, next data set is from a refinery. This is a quite straightforward use case. For an upcoming extension, the customer needed an accurate and updated model of this facility. Since we are talking about a relatively large area and a high building, and also no millimeter accuracy was really needed here, terrestrial laser scanning would become too expensive for this task. But because of the many pipes on different heights over and under each other, other solutions like photogrammetry was neither a perfect method in this case. BLK2FLY provided a grid solution for capturing, first of all, the cooling tower with all the small details on its roof. And the surrounding pipe system was also captured. And even though we were not really focusing on the area with the many pipes, which you're going to see in a few seconds, there's a whole lot of points, a lot of data collected on these pipes. So this can be used to check and update the models of this facility. We did focus on the tank on the other side. And as you see, here we have a very clear picture and a very clear 3D point cloud inclusive texture for the modeling of the connections, the tank itself, and the support structure under the tank. Our next data set is from the USA. It's a 10-story building, a very good high-rise example. 8 flights from the BLK2FLY covered this building. The data from all these separate flights were imported into Register 360, and based on the GNSS data, they came into the right position without any manual work. After a quick data check and cleaning, this is now ready for the architectural modeling of the building. The point cloud provides a good 3D underlay for the modeler, and the panel images, which you always have access to when you are flying with the BLK2FLY, is a good visual help for the modeler. The BLK2FLY turned out a perfect tool for the capture. Think about how hard it would be to capture all these small details on a 10-story building from the ground. Even the smaller details like the arc or the corner of the arc, and also the texture, so the colors are captured and included in the data set, making it a perfect 3D underlay for the modeling. Our last use case for today is rather special. The customer here was tasked with the 3D documentation of a support wall structure. It was needed in order to evaluate the status of these walls and create a model for an upcoming renovation. Climbing on this 4-meter high wall was not a feasible solution, and there was no usable opening on the wall. So in order to get information from both sides, a rather lengthy surveying process would have been needed, although the absolute coordinates were not really relevant in this case. After the capture, the raw data files were imported into Register 360, cleaned and finalized. As you see, we used the True Slicer tool to quickly check if we got the data from the wall, which we did. And then we went forward and we exported that area that we've been focusing on into an alias file, which later then we imported into Cyclone 3DR. In Cyclone 3DR, once we have the point cloud, we were planning to do some 2D and some 3D work, modeling and sectioning. But first we started with some cleaning. In order to focus really on the wall and the ground, we used the auto cloud classification tool within Cyclone 3DR to separate the vegetation from the hardscape and from the ground. And as you see, this is a very, very easy to use tool, which saves a whole lot of time when you are modeling. And when we could separate the wall and the ground, then we just went in and created 2D sections every meter, getting section data that can be exported into DXF and then used in AutoCAD or ArchiCAD or any other modeling and drawing tool. So as you see, it's a very detailed documentation, but it's also very easy to use downstream. Besides these 2D sections, a 3D mesh, a rough 3D mesh was also created for visualization and simulation purposes. This was then exported to a textured OBJ file, and it was used to do some simulations in a third party's software downstream. All this work and modeling and that we just saw was done in Cyclone 3DR. This is our all-in-one deliverable solution. And this is an incredibly powerful tool for working with point clouds, models, and meshes. You can learn more about this solution, Cyclone 3DR, in the webinar this Thursday. So make sure you register for it if you haven't done that before. You get the chance to learn from the biggest experts of this software. So don't miss this chance. And with that, thank you for listening in for today, and I hand it back to Brian to close this session. Thank you.
Thank you, Balint, for that deep dive into the case studies that we have with the BLK2FLY. It's very helpful for our end users and our customers to be able to see how we implement this technology so that they can better understand how they might be able to implement the technology in their organization. But it's not just about the BLK2FLY, it's about teamwork. The BLK2FLY, BLK Arc, and BLK2Go and HXDR with Cyclone 3DR make a perfect autonomous reality capture team and create the fastest scanning workflow in the industry. With BLK Autonomy, it's about moving into the future. The future is autonomy, and the future is here now. I'd like to thank you all for attending today's presentation. If you have any questions on the BLK2FLY or any of our technologies, please feel free, if you're in the US and Canada, to reach out to me directly at brian.baker@leicaus.com. If you're in Europe, you can reach out to Balint or Paul Burrows, who's conducting some of the other sessions as well. You can reach out to Balint at balint.rieger@leica-geosystems.com. Again, thank you very much for attending. I hope we found the information useful and beneficial. Have a nice day.